Hi everyone, welcome back to part 3. This time we're going to include some error bars on our data points here. Now, as far as the X values are concerned, they were the raw lengths, and when I was using a meter ruler to measure these, I measured them to the nearest millimeter as best I could, but it's a bit awkward with a pendulum, so I've been a little bit cautious here and suggested my uncertainty is 2 millimeters. So I could simply enter those. Now, all the same in this case. Not always the case though. When it comes to the Y errors, well, the Y values are times squared, and that's a calculation based on our measurements. So let's think about error propagation rules for a moment. You would be familiar with these error propagation rules from unit number 1. When we add or subtract measurements, in this situation, A and B represent measurements, and if I add or subtract them to get a result, then I add the absolute uncertainties to get the absolute uncertainty in the result. If I multiply or divide two measurements together to get a result, then I add the relative errors in order to find the relative error in the result. Now that's what we're doing. We're multiplying time by time. So capital T times capital T. We need this type of a calculation for uncertainty. So that's what I have down here. The relative uncertainty in time squared will be the relative uncertainty in time plus itself, or just double. Now, I already know the relative uncertainty in time. I've got that on my spreadsheet. And I already know t squared. I've got that on my spreadsheet. My error bar is just the numerator of this, the delta t squared. So I multiply the t squared through to this part over here. That's what I've written down. Now that is what I'm going to implement. I need 2 times the relative uncertainty in period times t squared. Let's do that. So we'll start a formula, 2 multiplied by. Now that cell contained the relative uncertainty for t squared, and that value is the value of t squared. So 2 times J4 times O4 implements that formula. It's a formula, Control C to copy, highlight the rest of the cells, paste formula. Now let's add those error bars. Come across to the chart, and we will put a tick for the error bars, and as always we'll move across to the more options. Now for the horizontal error bars, we could have simply put a fixed value in here, but I much prefer to specify the value of the error bars, and that's these numbers just here. They're so small they're almost invisible. Now if I click on the vertical error bars for a moment, it's changed over here to be the verticals. Again, I like to do the customize and specify the values. So that's this set of numbers. There they are. They're pretty small. I'll have to zoom in a fair bit to see them. I also note that I've got a fair bit of wasted space here on my chart. I don't really need to go less than 1 on the vertical scale because all of that space there is dead space. So I will format that axis to have a minimum value of 1. And then I notice here on the x-axis, I don't need to be going more than 0.7, and I probably don't need to be going less than 0.25. So I'll click on the horizontal scale, minimum 0.25, maximum 0.7. Now that's a convenient way of magnifying up what I'm looking at. So you can start to see the vertical error bars are appearing. These ones are quite small, so that's these ones all the way down here. Now, I do want to do a little bit more. That's a reasonable job so far. But I do want to be able to add in some extra features to this graph using linear regression. And that will be the topic of the next installment. Thanks for watching.